Hello, everyone. I wish to go over some complex fractions review for you. Okay, take the first one, for example. This is the complex fraction here. We basically have fractions in fraction. It takes some practice to be able to, just easily handle these situations. As you can see, when we have hiccups in algebra, our calculus grades will suffer. Okay, when we deal with these kind of fractions, what do we do? Well, it is just fraction in fraction. The typical way is we use mathematical principle number one. Okay, any number times one stay the same. So we start with the fraction, and equally we multiply by one. So anything times one stay the same. But we choose this one very carefully. How do we choose this one? This one is going to be numerator over denominator. We know these are going to be the same number. When we choose these numbers, it's going to be the common denominator of all four fractions. So the four fractions we have here is half, quarter, 5/8, 3/4. The common denominator here is 8. We multiply 8 divided by 8. And then we're going to multiply the numerator with the numerator, denominator with the denominator. And this fraction bar is at the same level of equal sign. Okay, don't mix it up. Okay, don't mix it up, because you put equal sign on the top, it's going to be very confusing for you and the reader. So be careful and write it down properly. We're going to take the 8, which multiply by 1, multiply the numerator, okay, with 8. And you do the same with the bottom. You do the same, you take this 8, you multiply with 8, right? And then 8 will be distributed to the inside the parentheses. So this half will be multiplied by 8, and a quarter will be multiplied by 8, right? And the 8 will be distributed to 5/8, and 8 will be distributed to the next one, which is 3/4, and the parentheses can be removed. And each one of these fractions will need to be reduced. So we're going to reduce that fraction. Okay. 1/2 times 8, that's 4. 1/4 times 8, that's a 2. 5/8 multiply 8, that's going to be 5, because 8 and 8 reduce. The 3/4 times 8, that's going to be 6. And we're almost done. So you can see we no longer have fractions in fraction. So now we have 2/11. So this is the general steps for reducing complex fractions. Okay, and you can practice with other exercises. Okay, so let me take another one. I'm going to take this. Maybe I'll take this one. Okay, the next example I'm going to do is going to be this piece. Okay, so we have big fraction bar, fractions in fraction, plus 7/x². Okay, denominator, we have 2 fractions, and we have 3/y². We have 4 fraction form. 1, 2, 3, 4. 4 fractions. and we're gonna find the common denominator. Okay, it would be better if you find the least common denominator, right? But if you find any common denominator, it will work. Okay, so we keep it. And we're gonna multiply by 1 once again. Okay, and of course, this 1 will be replaced by a number carefully selected. But if you look at the numerator has x as a denominator, x squared as a denominator. So we're gonna use x squared because x squared will be the common denominator for these two, and y squared will be the common denominator for the denominator. And so as a result, we're going to choose x squared, y squared as our common denominator for all four fractions. So we're going to multiply x squared, y squared divided by x squared, y squared. And we're going to do the same thing one more time. Okay, numerator times numerator, denominator times denominator. So on the numerator, we have x squared, y squared, right? We're going to multiply that with x squared, y squared. Usually this step can be, saved. You can go direct to the next step. But I like to do this because I can make it, I can check my work easily. Okay, so then I'm going to reduce. So let's reduce it. X squared and denominator x, so these two would just have x left. So here it would just be 1, okay? And x squared and x squared, these are reduced. So this will be gone, right? And y squared and denominator y, so these two are reduced. And y squared reduced with the y squared right here. Okay, you can even save this step and go directly to the next one. And now you're going to have 9 times xy squared, 7y squared, 5 times x squared y, and 3 times x squared. We usually would like to reduce it further, okay, to find common factors. The common factor on the top here is y squared, but there's no y as a common factor in the denominator. So if we factored out the y squared, it's not going to help very much. But if you like to have a factored form, right, which we typically like to have factored form, and we can factor out the y squared on the top, and in the and it will be left with 9x plus 7, and the bottom we can factor out the x squared, and we have a parentheses left, which is going to be 5y plus 3. So that will be the reduced form. But in the circumstances, because we did not do any reduction, there's no reduction possible. Okay, there's no reduction possible. So even if we just leave this step at the last step, that would be fine as well. Okay. And there are some other factoring questions, and I would take the next one, okay, which is this piece, okay, this piece. Fraction, more fraction. So we have a -2 over x minus 4 over x plus 2. On the denominator, we have 3 times x squared plus 2x plus 3 over x. Okay, you can see this is definitively a complex fraction. And the technique here we're going to work out, of course, is going to be multiplying by 1. Okay, we're going to find a common denominator. If it's the least common denominator, even better, right? But here, if you have a piece of scratch paper, when you look at x squared plus 2x, and you will realize that this can be factored. This can be factored into x times x plus 2. So this will probably help with, for us to get a simpler common denominator, or maybe even the least common denominator, right? So in the denominator, x squared plus 2x, which is the same as x times x plus 2, there is a factor x. So the least common denominator in the denominator for these two will just be x times x plus 2. On the numerator is the same thing. It's x times x plus 2. So we're going to use this common denominator, which is also the least common denominator, to make our 1. Okay, and then we proceed. And we take the numerator times the numerator, right? We're going to multiply. We take the denominator as a common denominator, right? Least common denominator, and do the same. And then we're going to reduce it. We reduce it one by one. And so here, this x will reduce with this piece, right? So now this is a -2 left. X plus 2 will reduce with the x plus 2 here. And x squared plus 2x, right? Here, we know they're the same, right? So this is going to be 1, and that is going to be 1. And x will reduce with x. Okay? You can skip this line and do it on the scratch paper and then leave this form here. So -2, 4x, 3, and 3 times x plus 2. Okay, so you could actually go from here directly here as you're getting better, but it's okay as long as you show the work that's correct, right? Or you can do all of these on scratch paper. All right, but anyway, those are details of how to show work. It's really up to us, right? So next we're gonna multiply out, right? We're gonna expand. So this -2 distributed to x, -2 times 2, so we get a -2x, -4, -4x. The denominator, we're going to distribute the 3 to inside the parentheses from here, okay? So 3x plus 6. And we combine like terms in the numerator and combining terms in the denominator. Over here, you're going to have 3x plus 9, right? On the top, we get a -6x, okay, -4. Can we reduce it further? Probably not. Okay, but we usually try it anyway. Okay, we try it anyway. We can factor out the 3 in the denominator. So we get x plus 3 in the denominator times 3. The numerator, we can factor out the -2. When a -2 is factored out, so we get 3x plus 2. There's no common factor. So you could leave your answer either in this form or that form. They're all simple enough. Okay. All right, last, I think I'm not going to make this lesson too long. Okay, I try to keep it short. It's the last one. Okay, so what we have here is 2 over x minus y plus 3 over x minus y and 5 over x plus y minus, x plus y, sorry, minus 1 over x squared minus y squared. By the way, the way to simplify complex fractions that is, the method we show here is not unique. It's not unique. It's not the only way. There are other ways. Okay. All right. So once again, we're going to get to choose our common denominator to make that 1. We multiply. Okay. So what do? Right? If you recognize x squared minus y squared is really x plus y times x minus y. And you can see the common denominator is all, it's right there. Okay. The common denominator is x minus y times x plus y. Makes the font a bit larger. And we do the same thing, distributing. And this is factor, we'll multiply that piece and multiply that piece and multiply that piece. And last but not least, and these equal signs are all justified by doing so. And then x minus y, take away the x minus y on this factor. X minus y, take away the x minus y on this piece. And so this is 1 here. And the x plus y, take away the x plus y over here. And x plus y times x minus y will reduce with this whole piece. Okay, so in the end or near the end, we have 5 times x minus y in the bottom, and this is just 1. The top is 2, and this is 3. And we probably attempt to try to see if we can reduce it, right? So on the top, we have a 2 times x plus y plus 3 times x plus y. So that's really 5 times x plus y. Can we reduce it? The answer is no. Can we take away the 5 and reduce the 5? The answer is please do not. Please do not. Why? Because there's a minus 1 in the bottom. That takes precedence before we can cross out anything. Okay, this is not a factor form that we can cross out the 5. Unless we have a 5 here. If we had a 5 here, yes, we can cross out all 3 5, but we don't. So we have 5 here, and this 1 doesn't have 5 there, so we have to leave it there. So that's the answer. That's the answer. So now let's look at our question on the quiz. Okay, on the quiz. This quiz question, which is finding the limit, was first presented back in, let me show you. Back in last week and before last. Okay, I think in week 2, you probably already see that question. Right? You see, we already have these reducing. And the question was asked. And I thought you guys might be prepared. Right here is week 2 homework. And week 3, in week 3, of course, it was given to you one more time in the circumstances of reducing complex fraction. Okay. And we have limit here. When h is approaching 0, this is something you are going to use very soon because we are quickly approaching other calculus contents which are derivative, taking derivative. Okay, we're gonna be approaching these contents in a matter of a couple weeks. Okay, some of you may say, oh, there's two variables here. Well, true, there are two variables, but you're going to be dealing with these kind of situations very quickly. However, since h is approaching 0, so you just treat x as a constant. Okay, treat x as a constant. And think of limit related to h. Okay, when h is approaching 0, denominator approaching 0, numerator approaching 0. So we have, once again, we have a situation with numerator approaching 0, denominator approaching 0. We cannot apply any direct substitution because you're going to have a 0 denominator. So we must reduce. Okay. If you want to do the algebraic part separately, okay, so I'm going to show you how we do the algebraic part separately. Okay. Applying the technique we just learned, right? So we're going to have to find the common denominator. What is the common denominator? What are the fractions? We have three fractions, okay? 1 over x plus h squared, and the other fraction is 1 over x squared. The third fraction is really h over 1. So the denominator is 1. So we really just have two fractions and finding common denominator. And that common denominator is the product of these two denominators. So x squared. Okay, so we're going to multiply x squared multiply x plus h squared. This is one of the way. I will show you another way. Okay, because I saw a person does that in class on the quiz. So I thought that's also a good way to approach. But anyway, so we multiply by 1. Okay, and then we do the same thing. We distribute the denominator, the common, this factor multiply this piece and multiply with that piece. And the denominator times denominator. So this piece will multiply that. Okay. When you are watching these lessons, please, you should have your notebook and paper, pencil with you and work alongside. And pause, rewind as needed, So next, we're going to do the reduction. X plus h squared, that's going to take away the x plus h squared. So this piece, we just have 1 left. Okay, x squared multiply 1 over x squared, so that's going to be 1. 1 times anything, you can omit the 1. So here is going to be 1, right? And we can omit the 1. Okay. And next, we still have a 0 divided by 0 situation here. So we need to continue to reduce. Okay, x plus h squared, and that equals to x squared plus 2 times xh, well, doesn't matter which order, plus h squared. Okay, and opened up the bracket, and so this is going to be minus, and this is going to be minus, right? Because you distribute the negative sign to each one inside the bracket. And then what? And then you're going to have x squared minus x squared. That's going to make 0. Right? So this is gone. And the next step, we can factor out the h. We can factor out the h on the top. Okay? You can even factor out the negative h on the top if you wish. Okay, so negative h is factored out. Parentheses, this h is gone, so we only have one h left. And of course, this is going to be plus, right? Factored out the negative h. So negative h is out, and minus h times h, so negative h is out. So we have 2x plus h. You can check it by, distribute negative h times 2x, you should go back where you came from. Okay, and next we can reduce the h. We can reduce the h. This h is gone, and this h is gone. Now we have, what situation do we have? When h is approaching 0, we're not going to have 0 denominator. Okay, we're not going to have 0 denominator. So the limit of that piece is going to be the same as the limit, right? This whole piece is reduced to this point, so we're going to replace it. Okay? Now we can do direct substitution, because if you treat x as a constant, h approaching 0, we can do direct substitution. We can do direct substitution. Okay? Substitute h by 0. So h is replaced by 0, h is replaced by 0. So in the end, we have numerator we have negative 2x, denominator, we have x raised to the power of 4. Reduce the x, we have negative 2 over x raised to the power 3. Okay, so that was the question on the quiz, the second question. Okay. All right. Thank you for watching. Until next time.